Guys, so in this video we're going to be talking about simplifying exponential expressions. So simplifying exponential expressions, you need to remember a couple of rules for this, and I put the rules up here. The first rule being that if you have two numbers or two terms that are multiplied with the same base or same number under the variable, or under the power, I'm sorry, you add the power. So x to the power of m multiplied by x to the power of n, how many x's do you have? Well, you just add them up. So x to the power of m plus n, you add the exponents. If you have a power to a power, so an exponent to an exponent, you multiply the exponent. So x to the power of m, and then all that to the power of n, you multiply them together. So it's x to the power of m times n. Lastly, if you have more than one term inside, that term could be a number as well. And you have these guys to a power, and then that whole thing to another power. You use the distributive property, power to a power. So it's going to be x to the power of a times c, meaning that times that, and then multiply by y to the power of that times that, or b times c. Okay, we're going to be using these three rules in this video to be able to simplify exponential expressions. All right, so I'm going to keep this up here for reference, and hopefully it helps you guys out on your simplifications. So first of all, examples 1, 2, and 3. How do we simplify these guys? So we worked through the first one. We have a to the power of 5 multiplied by a to the power of 7. If you look at one of the rules, all you have to do is add the powers. How many a's do we have? So we have a to the power of 5 plus 7, right? What's 5 plus 7? Well, that's just 12. So the first answer is a to the power of 12, if you simplify this expression. Okay, example number 2. X to the power of 2, and then all that to the power of 8. Well, if you look at this rule, it means you have to have a power to a power, which means you multiply the exponents. So that becomes x to the power of 2 times 8, which is 16. In this case, we have more than one term, right? 2, a to the power of 3, b to the power of 4, and then all that's to the power of 2. So really, really important here is that every single term inside of a parentheses has a power, even if they don't write it. If they don't write it, it's going to be always to the power of 1. So I'm going to go ahead and add the 1 in there. So it's 2 to the power of 1, a to the power of 3, b to the power of 4. We have this guy that has to be multiplied or distributed to every single power here so we can simplify. So that expression becomes 2 to the power of 2, right? Because 1 times 2 is 2. And then a to the power of 3 times 2, which is 6. And then b to the power of 4 times 2, which is 8. Okay, so we have this. All you have to do now is simplify. So can you figure out what 2 squared is? You better, right? 2 times 2 is 4. So number times himself. 2 squared is just 2 times 2, which is 4. A to the 6, b to the 8 as our final answer. All right, let's do some more examples, a little more complicated now. So we're going to level up a little bit. So example 4 and example number 5. How do we simplify these expressions? So we'll take it one step at a time. First of all, parentheses. Let's check if the parentheses have any powers on the outside, for example number 4. Since they don't have any powers on the outside, then you don't have to distribute anything on the inside, right? So parentheses means multiplication, so everything here is multiplied together. That being said, the 2 and the 5 are being multiplied, right? The coefficients. They're still regular numbers. What's 5 times negative 2? Well, 5 times negative 2 gives you negative 10. So that number in front of the expression would be negative 10. Then we got to worry about the x's. We have x to the power of 2 here, x squared, and then x to the power of 3. Again, it's multiplied. How many x's do we have? 2 plus 3 would give you 5, so this becomes x to the power of 5. This is one of the rules of multiplication. When you have multiplication, you add the powers. Lastly, we have the y's, right? We have y to the power of 3, and then that is being multiplied by y to the power of 5. If you add those two, we have a total of 8y, so it's going to be y to the power of 8. So our final expression is going to be negative 10, x to the power of 5, y to the power of 8. Okay, so not really that much work to show here. Let's do example number 5. So same idea here, but be careful because this time we actually have powers on the outside. So we have this whole thing to the power of 3, this whole thing to the power of 3. Notice some of them, they don't write any powers. When they don't write a power, especially the numbers, it doesn't mean that they don't have a power. It means that they're actually to the power of 1. So this is 3 to the power of 1, x to the power of 2, y to the power of 3. here we have negative 2 to the power of 1, x to the power of 1, y to the power of 1, and then all that to the power of 3. So we're going to have two distributions. So this is where it starts to get a little more involved. You're going to have a little bit of extra space on your paper so you can do the distributive property and expand this. So this actually becomes, I'm going to write it down here, 3 to the power of 1 times 3, which is 3, x to the power of 2 times 3, which is 6, y to the power of 3 times 3, which is 9. Okay, and then that's set. Now we just have to do this one. So this is multiplied by negative 2 to the power of 3 times 1, which is 3, x to the power of 1 times 3, which is 3, and then y to the power of 1 times 3, which is again 3. Okay, so we have all this nonsense that we can simplify. Let's deal with the numbers first. Can we simplify the numbers? I think we can. So 3 to the power of 3, that can be a whole number, right? 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. So this becomes just 27. So that became 27. Can we simplify this guy right here? Yeah, I think we can. So that becomes negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is positive 4, and then positive 4 times negative 2 is negative 8. So this is multiplied. I'm going to write, everything's multiplied together, guys, so don't feel like you have to write them in a specific order. So I'm just going to write negative 8 right in there. Because the order for multiplication doesn't really matter. 2 times 3 is the same as 3 times 2, so don't feel like you have to do everything in order. So that became that became that. Now we just got to deal with the x's and the y's. So if we deal with the x's, we have 6 x's here and 3 more x's there. How many x's do we have in total? 6 plus 3 equals 9, so this is x to the power of 9. All right, now we just have to deal with the last one for the last term. We have 9 y's here and 3 more y's. So that's 12y, so y to the power of 12 as my final answer. Now, we still have to multiply the numbers in the front. 27 times 8. Anybody know what that is? Me either, so let's multiply this really quick. So 27 times 8. 7 times 8 is 56. So 6, carry the 5. 8 times 2 is 16. 17, 18, 19, 20, 21. So 2, 1, 6 as our final answer. And that is a negative 8, so it's going to be a negative 216 x to the 9, y to the 12. So after it's all said and done, this is our simplified exponential expression. Okay. Hopefully this video was helpful. Again, take it step by step. Everything is multiplied, so the order don't matter. Power to a power, you multiply the exponents. Every single number has a power, including the numbers. So it's to the power of 1 if they don't write anything. Okay. So hopefully this was helpful. See you guys in the next one.